left, you have American Lion Corps. In the middle, there's Jason Trout and Charles King. Our project is entitled High-Speed Position Tracking for Virtual Reality. We decided to break up the responsibilities into groups. Charles and Amir were in charge of selecting an accelerometer as well as designing the algorithm to convert the accelerometer information into position data. Jason lent his expert programming expertise to designing the user interface as well as helping to implement the algorithms and for code support in general. And I designed the vision, the computer vision component, as well as coded that myself. So essentially, what our project does and our prototype is it tracks your position in the real world as you move around in a predefined area, and takes that data, maps it one-to-one with virtual coordinates, which can then be used to control a camera in a virtual reality environment. Our goals were for it to be low cost, have low latency, be precise, as well as portable. There are similar systems on the market like this, but generally they're very expensive, and really none of them are great. We're trying to kind of start over with virtual reality as opposed to the millions of dollars that have been spent, or because of cell phone technology, there's a lot of new things that can be done. So essentially, the way we implemented this was we used two sensors, the first being an accelerometer to track position data. You can double integrate the acceleration data and come up with position, but you do get significant drift, and it's very sensitive to noise. So we integrated a second sensor using computer vision and a camera. We create a second set of coordinates. We take the coordinates generated from the accelerometer, we add them to not add them directly, but we combine them with the camera coordinates, generating a final set of coordinates. Those coordinates are then passed into a computer which can use those coordinates for whatever simulation it desires. Any questions?
So you mentioned that one of your targets was accuracy and cost. Did you meet those targets?
I would say accuracy was we definitely met the cost requirements. Our costs were very low. We simply used, what did the first accelerometer cost, something like that. And then we also had a very affordable camera that we use, a webcam. Now, you can improve upon our system with a better webcam and with a higher frequency accelerometer, but it was very low cost. As far as accuracy, in the second semester, we reevaluated our target, and essentially we were trying to, our vision sensor is pretty accurate, but our accelerometer tracking was very poor, so we stepped away from that and used it more to track the direction you were moving to verify the vision sensing side of that. So it is accurate intermittently. Yes?
Yeah, one camera, right?
Yes.
Okay, so therefore you could do X, Y, you want to do.
We do X, Y, and Z. We can. Right now we're only doing X and Y. But
How do you do that?
well, you notice this big green ball on top of here?
Yeah.
Essentially, the camera processes the image. It detects the size of that ball in the image, and based upon that sphere, it can tell spherical coordinates.
That's your distance limit.
Yes, that's your distance and also angular. So it gives us spherical coordinates.
Well, yeah, the center of it.
Right. Yes.
So I guess in the motion tracking model here at UTD, where we're doing a lot of
Yes.
these things, is the approach you're using are similar to what's implemented in that motion tracking lab, or for example?
I don't think so. I actually only discovered we had a motion tracking lab about halfway through senior drawing. And I went over there and did a demo with them. And I'm pretty sure that they're not. I'm pretty sure they're using stereoscopic vision. They have, like, I don't know, 25 cameras in there from every angle, as well as some infrared blasters and stuff. And which is like, hundreds of thousands of dollars set up. This literally cost us less than $200 probably. I'm sure it's not as good at this point, but I see a lot of ways to improve it. I was displaying this as a summer semester because we were more time and more things I'd like to do. Yes?
Why not doing everything with image processing and camera? Why do you need accelerometer?
Well, one of the most important things about VR is that you have low latency so that you can update the frame in as close to real time as possible. And accelerometers right now that are directly can give you, really high frequency samples. So that would allow us to give very, not precise maybe, but very constant information. Whereas the image processing takes more time, it's dependent on the frame rate of your camera as well as how long it takes for it to process each frame. So our thinking was that that would be our primary source originally, that would be our primary source of data, and then the camera would correct for the error of the accelerometer. Later we found that the error of the accelerometer was so significant, we hadn't solved that problem completely.
What would be the advantage of this over like using a Kinect sensor? I guess a lot of people just buy on the shelf Kinect.
Yeah, I mean, VR has kind of had a small revolution lately, and a lot of people just slap a Kinect on the outside of it, but that has the same problem. It's very low latency. A Kinect has between 120 or 170 milliseconds of latency. And so what we're trying to do is remove that down to something that could really be viable for VR, for immersive VR, and won't make you nauseous. Yeah.
Have you thought about using maybe a common filter that increases your update rate?
Yeah, we did, and that's absolutely the best thing to do. Basically, that was beyond us in the time period that we had. That would definitely be what we need to do to integrate our two sensors, is probably use a common filter.
The John Hint's question is, what was your accuracy?
Well, our accuracy right now is not real good. I mean, basically, for our camera, it's pretty good, but it does have to be in a controlled environment.
8 inches or angle or...
Oh, we're doing like, right now I can measure and it'll probably be off by 10% as far as if I'm a meter from my origin, it might occasionally fluctuate between 90 centimeters and 110 centimeters as far as my axes go. So it's about 10% off right now. But again, that's mostly because we're talking about using a controlled environment for one. And right now, we haven't really tested in a controlled environment because none of us own like a big warehouse that we would need to test. And so one of the things is we're filtering out background noise through color. And if like out there in the hallway right now, it doesn't work very well because there's so much direct sunlight. But you can calibrate to each environment separately, but some environments work better than others. And the application of this would be something like a warehouse where you could go and play in whatever virtual world you want to. So that environment would be completely controlled. We'd have control over the lighting, we'd have control over the background and whatnot.
So last semester, I think you said you wanted to get your latency down to like 10 or what was that?
Well, we have low latency, but then we have poor accuracy if we have our low latency.
So where did you settle?
Well, what ended up happening is we changed our accelerometer really more recently in the last couple of months because we found that our accelerometer was getting so much noise that we had to change our project completely. And now we replaced that accelerometer that we purchased with an Android device because it was easier to get accurate, or if I shouldn't say accurate, it's already filtered information from the Android device. So as of right now, our latency is what is it? I think I got about 30 milliseconds, which is pretty good. But our accuracy from the accelerometer when we do that is I don't have an exact number, but it's not very good right
You have a set better?
now. Yeah.
Right, so one last question, go ahead.
I'll just say, over the past year, the department has had students doing internships at Sony PlayStation and Microsoft Connect group. So, it'd be cool to try to get those students to come play with your setup and see what.
Thank you.